Welcome to Learning Analytics Tools course. This is Introduction to Machine Learning Part 2. So in machine learning there are 4 steps. The first step is data collection and data processing. This is similar to what we saw in learning analytics. In this step we have to decide what data to collect and why we have to collect, and importantly we should make sure that the data is available or not. Also we have to do the data pre-processing, like removing the missing values or outliers, ensure that there's no bias in the data. Also, if you find any errors, you have to remove those data. The second step is choosing model or algorithm. That is like which model to use for the data or research question you are selected. This step includes decision of choosing the suitable algorithm. And the third step is training and testing. So now you have data, you collected data, you have research question, and you also have the model to use it for your analysis. And the next thing is you have to train and test. So you have to classify your data into training and testing data and use the data for training and testing. Training involves the process of determining the parameters of model using the data. You are creating model using the training data, and testing data will be used to evaluate the performance of the model. You can create more than one model and you can compare the performance of the models using the test data. So let's look at the type of ML algorithms. There are 4 types: supervised learning, unsupervised learning, reinforcement learning, and recommender systems. In this course, we'll talk about supervised and unsupervised machine learning techniques. So what is reinforcement learning? Reinforcement learning is mostly used in neural networks recently. And recommender system is the system which in an education context, which recommends based on the student's interaction, it recommends what to do next, like provides you the questionnaire or new content or new example, something like that. In a recommender system, in other contexts, it can be recommending a new algorithm itself or recommending a new program, a new strategy, something like that. Let's start with the supervised algorithm. Supervised algorithm is a developer model or function that maps an input to one output with the help of labeled data. So you have to find the mapping between the input and output. What is input and what is output? Let's see. For example, you have collected the data of 3 students here. You collected the data of 3 students, and your data, that is the average session time. Imagine they are working on MOOC or a metal kind of tele. Let's see, it is a MOOC. First, you have to see average session time. So in a MOOC, they might be logging into the course for several times. So what is the average session time the student when he is interacting with MOOC? So I say 34 minutes. It's given in minutes. And number of videos the student watched overall, maybe 12 or 30 or 25. That's the number you want, second feature. The other input we can have is average time on each video in minutes. Like you watched 12 videos, but what is average time spent on each video? Say 2 minutes. So some videos you might have watched more than 2 minutes, some videos you might have watched less than 2 minutes, but that's average you can compute. Also, we can talk about number of interactions in forum, like a 10, 20 or 6. So I assume that there are 4 features I can collect from the MOOC data. I have a log data. I computed these 4 features using Excel or written some script to capture it from the raw data. Also, I have the students' performance in their final exam or the exam conducted after the MOOC course. So I have the final exam here. I will consider this input, that is which I can observe, like x1, x2, x3 or x4, all as a features like xi. The I here is 1, 2, 3, 4 features, and I will consider this performance as a predictive value or a dependent value. This performance is depend on these 4 values. So that's why it's called dependent value. These are all independent value. So we call that as a y, that is the performance as the label y, and si is the features x1, x2, x3, x4. Here I have a student A1, A2, A3. Now we want to create a model for these data, so that if a new student A4 comes with say different time 42 and number of videos watched, it is say 36, and you watched only 1.5 minutes, number of interaction is say 30, what will be the performance? So the idea in machine learning is that you have a supervised data, that is you have students interaction, that is observation input data, also the label, create a model using this data and test it or predict the performance on the new student or new data you are yet to see. That is a machine learning. Supervised learning means. Let's understand what is the uh, now let's understand what is x, y, x1, y1 means. So a label data set, that is xi, yi, where this yi could be either an element belong to a finite set of class or a real number. So the xi that we saw in a previous slide, that 4 features we collected from the MOOC data interactions. Yi over there is performance or student score. The yi can be pass or fail, or a real number as we saw in the last example. Pass can be denoted as 1, fail can be denoted as a 0, or it can be apple, orange, or other fruit. We can denote this as 1, 2, 3. So now the yi is set of 1, 2, and 3 in this example. Similarly, yi can be 0 or 1, it's a binary, it's a real the set of numbers, or the real numbers as we saw in the previous class, like performance in the exam, like 63, 40, or 70, something like that. So examples for supervised algorithm is that we can predict students' final final exam scores, like based on the interactions or based on the interactions in the class, in the environment. Or we can predict in MOOC which user will drop the course in 5 weeks or 6 weeks, something like that. The dropping will be binary classification, saying that he will drop or not drop. Or which user will uninstall the app, that is churn rate. Suppose consider you are creating a education mobile app and we want to know which user will uninstall that app and when they will uninstall. Can we predict it based on their interaction with the app? Then you are predicting whether uninstall or install, churn rate, that can be again 0 to 1 binary classification problem, and predicting the student's performance in a next question. That is more finite level prediction, that is based on the student's interaction with the system for say last 10 minutes or last couple of sessions. You want to predict whether the student will answer the next set of questions given to him or not. If the student is not going to answer, you might consider giving the less difficult questions or providing hints or asking them to read something that will help the student's time, and also student can learn better. So these are the examples of supervised learning. In this all examples, we know we want to predict the students something like a final exam score. We should have the final exam score, we can collect it. Also, we want to know whether students drops the course or not, you know what to predict. You know what is the value you are going to predict. Also, you have to come up with the set of input features like x1, x2, x3, x4. So then supervised learning, you know what is the input, also what to predict. If you have both x1, xi and yi, then it's considered to be a supervised learning approach. So given the examples you saw in the previous slide, can you list down other 2 examples for the supervised learning problems from the data collection we discussed in the last week? List what is the independent variable, that is xi, what is the dependent variable, that is yi, that is label. List down 2 problems and list down its independent variables and dependent xi and yi. After listing it down, resume to continue. So you might have listed down some of the examples like xi, yi. So let's consider that you have xi and yi. Say there's a simple example, students ID, there are say 7 students and we have the attendance percentage in the semester. Also we have their final marks in the semester. Now this is xi and this is yi. I want to predict the students final map score, final marks in the exam using the attendance percentage. So or you can have a multiple input values, say x1 and x2, for example attendance, also the midsum marks. So I have 2 marks, 2 data and input features. I want to predict the students final marks. So that is yi. The y1 is the final mark, it's a real number, and x1 and x2 is here. So in this case, we have both x1, x2, also the final mark. So this is a supervised learning technique should be used for the prediction. So what is unsupervised learning? So we said that supervised learning has both xi and yi. Unsupervised learning has only the xi. We don't know what we want to predict it. Or that's like we have observed the students' interaction, but not sure what to predict. That's one thing. Or you don't have historical data. That is that in a previous slide, we saw that students' attendance, midterm marks, and exam scores available. But that data available from your previous year's teaching record, or some data available already. Some students have taken the exam and everything. You want to predict the students' performance in the current batch. You don't have any historical data of the score or something. In that case also you can use the unsupervised learning approach. So in unsupervised learning approach, we have x1, x2, there's no y, we don't know what we are predicting, but we have collected a lot of data, engagement, everything. We want to see if there any pattern evolve from the data or any clustering happens from the data. For example, given a new article, given a news article, classify the news article as a sports, entertainment, and politics. In the Google News, it happens automatically without having labeled it as classifying a sports or entertainment. Or if we had a lot of human data labeled all these news articles automatically, then this is a supervised problem. Consider there's a given news article, a topic, one news item. Say there was a festival in a particular state, and we want to collect all the related articles from the different newspapers. If you want to collect about that particular news from a different newspaper, news publishers, then it can be an unsupervised algorithm, because we may not know labeling of this algorithm ahead of the time. So there, the system automatically groups the similar newses. For example, festival in a state Uttarakhand, and if you want to consider that news, it uses the keywords in those news articles and tries to find is there a similar keyword available in any other news magazines or newspapers. Then it collates everything together and puts it under one particular news heading. If you go to Google News and if you use it, news.google.com, you will see this kind of grouping together happens using unsupervised learning algorithms. And other one is group users based on their profile data. Suppose you want to create a project or a lab course or something like that, and you want to group the students based on profile data, like based on their previous background or the branch in their class 12 or the diploma or some other thing, or their background information. You can group that information and you can create groups and assign some tasks to them. Or group the students in a class based on engagement in the class. There are some students who are highly engaged, some students who are not engaged. You might find a grouping of these students, and you may want to mix them to make a better peer learning or something like that. So in a nutshell, there's a difference between unsupervised learning and supervised learning is, consider we have attendance in percentage, midterm marks. If I plot that in x and y axis, and I have plotted like this, and I have no idea what is this student belongs to, what is this student belongs to. So if I apply a grouping algorithm or clustering algorithm, I can group this as one group and this as a second group. Or I think if I want to apply further, these two groups may not be correct, I want to apply three groups, maybe I should go and create a new group. Maybe this is a one group, this can be the second group, and this can be the third group, and this can be the fourth group. How many clusters is good, 2 or 4? That we have to identify by using the mechanism of errors or minimal errors. We will talk about that later in a clustering class. So given this data without any label, we can group them into 2 groups or 4 groups. So clustering algorithm can identify the groups with a similar behavior in the data. Whereas in supervised algorithm, we know there are 2 groups here. These students have scored less than 70 marks in the final exam, and these students have scored more than 70 marks in the final exam. So this is a exact two class classification problem. This is a class 1, this is class 2. Class 1 is less than 70 marks, and this is equal to or greater than 70 marks. So now you know the label Y and you know the X1 attendance and X2 midterm marks. Now this is a supervised learning problem. In this problem, we have X1 and X2, we don't have Y. So it is not a supervised problem. We can come up with the clustering, say 2 clusters or more than 2 clusters, depending upon the data and the interaction behavior, how they interact with each other. We'll talk about the clustering in detail in a separate class. So this is to introduce the difference between supervised and unsupervised learning. So since you have seen supervised and unsupervised learning, can you list down 2 unsupervised learning problems from a data selection we did in the last week? After listing down, please resume the video to continue. So as I mentioned already, you can use this unsupervised algorithm to form groups for class project or form a lab project. You may not want to form a group with a similar set of students. Instead, you want to mix and match. For that, first you need to find what are the students' behavior, similar groups. Or you can use this unsupervised algorithm to provide remedial content or extra coaching to them, or you might want to give exam which is less difficult, or teach a special course or something like that. Or you can compare the behavior among 2 groups. If you have a group A and group B, and you can identify patterns among these 2 groups and compare the patterns of group A and group B. The patterns can be like what are the actions they do. You can identify mind patterns in the unsupervised algorithm. Also, you can develop clusters based on interaction data in Moodle or Tele. So the interaction data, we can use it to create clustering algorithm and create clusters to group the students into multiple groups, and you can provide different level of recommendations to them. So here we have types of supervised learning, that is classification and regression. In supervised learning, classification again goes to binary classification and multi-class classification. And we saw that binary classification has a 0 and 1, multi-class can have 1, 2, 3, 4 or apple, banana or something like that. In regression, the Y is usually the real number, the continuous variable, like the performance 65, 70, 75, something like that. So in a classification problem, it aims to develop a model that could help in separating data into multiple categorical class. That is, in this class, I want to set into 2 class. I want to set into 2 class. I want to 2 class. So it's a binary classification problem. The goal here is to predict the class or category to a particular instance will belong to. For example, if I have a new data, say new data with attendance, 63. And the midterm marks is say 40 or 50. Where this data belongs to? This data belongs to class 1 or class 2? It's based on where you draw this line, right? How do you draw the line? We will talk about that in detail. It's based on where you draw the line. Suppose if I have a line drawn on suppose if I have a line drawn like this, this data might belong to the other class. So it depends on the where you draw the line. We'll talk about that in detail. But if in a classification algorithm, when a new data comes, the goal is to put the data into either this class or that class. In regression, again it is subdivided into multiple, like a simple and multiple. In simple, it's a linear, non-linear, and also in multiple, it's a linear, non-linear. We will talk about a simple linear regression now. The output is the continuous variable. This is the same plot we discussed a few slides ago. There's attendance and the final marks. If I draw a line, a linear line, which fits all this data, which assumes that there's a linear relationship between attendance and final marks, and I have to fit these values in a linear line. So the simple linear regression aims to fit this 2 marks, like a x1 into y1. For example, I'll just go here. So this is xi, this is yi. It's trying to fit the linear relation between these two. It assumes that there's a linear relation between these 2 variables. Consider there's a new data or new student with attendance equal to 65%. So what will be the student's mark in the final exam? So since we fit this line using a linear regression algorithm, we can able to tell what will be the student score in the final score. Since it is 65, we can draw the line and the mark will be around something like 68 or 69 or something like that. So, in a linear regression algorithm, instead of classifying in the new students data into either class 1 or class 2 or class 3, we are trying to find their score using the continuous variable. So, you have seen just the introduction of classification and regression. We will talk about this classification and regression algorithms in detail, but given the introduction of classification and regression algorithms, can you list down minimum 2 differences? After listing it down, resume the video to continue. So, the classification algorithm creates a model to group the data into 2 or more classes, binary or more not binary classifiers. The data, the Y is usually the discrete or categorical, where like example, student will pass or fail, student will get more than 80 marks or not, something like that. Whereas in regression, the model trying to fit the given data points, that is xy to the xi to the y. Also, the y is continuous data, it's a real number, and it's trying to predicting the score. For example, a new student comes, what will be the score, instead of trying to put him into whether the student will pass or fail, or student will get less than 70, more than 70, or more than 80. We're trying to predict the score. That's why the difference between these two. So, there are few algorithms for supervised learning, that is linear regression, nearest neighbor, naive Bayes, decision trees. We will see these algorithms in detail, not support vector machine or random forest, but we will see the first 4 algorithms in detail. For the unsupervised learning, there are 2 types, again clustering and competitive learning. Like we saw in supervised learning, there's a classification regression. In unsupervised learning, there are 2 types, like clustering and competitive learning. In clustering, again, there are many types of clustering. We just gave 2 of them here. So, K-means clustering and hierarchy clustering. We will discuss this in detail. To summarize, in this video, we saw what is supervised learning, what is unsupervised learning, and we saw unsupervised learning, what is type of supervised learning algorithms such as classification and regression. In unsupervised learning, we saw a clustering technique. We didn't discuss much, but we introduced what is clustering. We will discuss each of this algorithm with example algorithm in detail in further classes. Thank you.